Jai Hind all of you. I am Harsh Mohan Sharma, Assistant Professor in Ajay Kumar Garg Engineering College from Electrical and Electronics Engineering Department. So in this lecture, we are going to continue. In the previous lecture, we were talking about different types of signals, that is classification of signals, and we were on periodic and aperiodic signal. So a periodic signal we have already discussed as a signal which repeats itself after some certain point of some interval of time, and that interval of time is basically known as fundamental time period. Okay, so yes, so it was the fundamental time period, and yes, so the fundamental time period is the minimum time period after which the signal is repeating itself. Okay, so it can be expressed by this expression, that is x of t is equals to x of t plus n t naught, where t naught is the fundamental time period. So this was about the single signal, right? So if we are having a combination of signals, right? So if we have complex signals, complex means that it is a combination of two different signals. So the procedure is we will find the time period for each signal, and if this property, this condition holds, that is the ratio of the time periods is a rational number, then we can say that that particular signal will be periodic. And how the that time period of that signal can be calculated. See, here are some examples which depicts that we are having some numericals over here. So by these numericals we can see how the time period of a complex or combination of signals can be find out. See, here as in the previous slides we were talking about, this is actually the ratio, or we can say that this is the condition by which we can state that if it is rational, yes, the signal will be periodic. And yes, if we are having t1 and t2, that is the time period of first signal and time period of second signal. So if we take the LCM, or it is a ratio of the LCM to the HCF, then we can find that yes, that's the time period of the combination of signal. So it is nothing difficult, that you just have to find out the LCM of the both the time periods and HCF of both the time periods, and just take the ratio. So whatever the ratio is, that is the time period of the combined signal, right? So there are some comments in the section, which means that if time period is t, then x1 and x2 will be complete m1 and m2 cycles respectively. That is basically depending upon the frequency. On the other hand, if the ratio of the t1 and t2 is an irrational number, then it will not be periodic in nature, right? We can easily find out the above similar results with the discrete time function. So whatever holds with periodic functions, so that is continuous time signals, so the periodicity is also applicable to discrete time functions, right? Now here are some examples that if we are having x of t, that is one of the signal, it is equals to cos of t plus sine of t, then you have to find out whether this signal is periodic or not. So we can see that this is first signal, this is second signal, and cos of t, it's this is periodic signal, and its time period is 1 over here, that is cos omega t. This is the general representation of cos signal. So if we can say that this is omega, that is t1 equals to omega, and here for sine t, that is if we compare sine from sine omega t, so here omega is 1 and t2 it is also 1. So if we take the ratio of t1 is to t2, so that comes out to be 1, and it is basically equals to omega, that is 2 pi. So it is the time period of that combined signal, right? Similarly, if you are having x of t is equals to 2 cos 2t plus sine of 3 by 2 t, so here we can see that first, that is first signal, that is cos 2t. So here t1 will be pi, okay, so type t1 is pi over here, and for the second signal sine 3 by 2 of t, it is 4 pi by 3. Now if we take the LCM and divided by HCF of both these, so we will get 4 pi, right? So this is the time period for this combined signal, okay? So similarly you can do all these numericals and find out the time period of each one, right? After that, the next classification is deterministic and random signal. So as the name suggests, what is deterministic and what is random? So deterministic is something which is actually known at a particular instant of time, or the pattern is followed. Okay, so if the pattern is same, we can just predict the future values of any signal, right? So signal which is, it is those signals are said to be deterministic if there is no uncertainty with respect to its value at any instant of time, right? So if we know the proper pattern of the signal, just like this is sinusoidal signal, and we know that if it is pi, for pi it is 0, then for 2 pi it will be again 0, at 3 pi it will be again 0, and its maximum value will be at pi by 2, right? Similar, that's the pattern which is this signal is following. So there is no uncertainty that at any instant of time, it is not like that we cannot find the value of this signal. Okay, so yes, it is a signal which is exactly determined or exactly have some certain values, or that can be predicted in future time respect, right? Or we can say that signal which can be defined exactly by a mathematical formula, which is also known as deterministic signal. So yes, by the mathematical formula means x of t something equals to, so here we are having t, and this t can be any time of future or past or present, right? So during the calculation, we can just put the time value over here, and we can have the magnitude or whatever the value of the signal. So this is deterministic signal. So just opposite to that, it is random signal, or random signals are also known as non-deterministic signals, right? So as we were having some pattern over here, and the values were actually known, or we can say that we can predict the value. So just opposite to that, here we cannot predict the values, right? So it is unpredictable, and that's why it is known as random signal. Okay, so we cannot determine its values of the future. So this is all about, and see, this is cannot be described with any kind of mathematical equation. So deterministic can be represented with mathematical equation, non-deterministic or random signal will not have any kind of mathematical equations, right? Then another one, that is another classification, is energy signal and power signal. So energy signal and power signal is basically, they are kind of signals which are available in electrical energy system, or we can say that not particularly the electrical energy system, rather we can say that each and every signal has some energy or power. Okay, so depending upon the value, or depending upon the magnitude of the energy or power, we can say that the signal is energy signal or power signal, right? So we will talk about energy and power signal in electrical point of view only. See, we all know that the instantaneous power in any circuit, or if particularly talk about DC circuit, then the instantaneous power is given by P is equals to V of t multiplied by I of t, right? So here we can see that this voltage or current, see, they are just replaceable, so we can just replace I is equals to V upon t, or similarly we can replace V by IT, RI, not IT. So we will get this equation, that is P of t, that is power is equals to V square upon t, and which is further equals to RI square. See, this representation, this is the representation of the power into the circuit at any instant of time, right? So we can calculate the power, or we can calculate the energy of the signal, see, by this formula. Here it is, see, energy and power, it is available from some particular interval of time, or we can say that some instant of time to another instant of time, or we can say that for minus infinite to plus infinite. So in this time range, each and every time period is considered. So energy infinity, okay, so E infinity, this is representing the energy which is possessed by signal for complete time interval, right? So it is given by limit t tends to infinity, integration upon minus t to plus t, and square of the magnitude of the signal, that particular signal of which we are calculating the energy, right? So it is mod of xt whole square dt, right? And it can also be written as, if we just replace the limits, so from minus infinite to plus infinite, mod of x, or we can say the just magnitude square, and from this we can calculate the energy of signal, and the power of the signal can be calculated by this one, that is 1 upon 2 pi, or if we are talking about if time is in the range of pi, then it can be 2 pi. So but ultimately here we are just using 1 upon 2t, that is it is having some just like this one time range, right? 2t, t is some sort of particular interval of time, right? So similarly, if we divide this energy or this formula by 1 upon 2 pi, basically this time range, then we can get the power of the signal, right? So now if you calculate power and if you calculate energy, then after this, depending upon the values of these energy or power, the signal will be defined as energy signal or power signal. And so see how they are defined. If a signal is finite, see, if a signal having total energy is finite, see, if finite means 0 to infinity, somewhere it is lying, if it is lying between 0 to infinity, then this signal is known as energy signal, and this kind of signal will have its power equals to 0. Okay, see, we are just dividing it by the range upon up to which we are just integrating it, so it is just the average power. That's why it is also represented by P AVG, right? P infinity or P AVG, right? So for this kind of signal, if it is energy signal, it will be having some finite value of energy, and for that signal the power will be 0, right? Since from this equation we can say that power will be 0. Now if signal is having some sort of power, okay, some sort of, if we calculate this power, and if we get some finite value means between 0 to infinity, then this is referred to as power signal, and under that condition it is mandatory that it is having energy equals to infinite, so it is known as power signal, right? So examples are, for energy signal we can say that k some constant multiplied by e to the power minus at ut, so this is one of the power signal, and k times of ut, this is energy signal, sorry, this is power signal and this is energy signal, right? Now the signal with the infinite total energy and infinite average power, they are actually referred to as neither energy nor power signal. So these kind of system signals also exist in the nature, just like kt, so they are continuously just like increasing, it is a ramp signal, so it's neither energy signal nor power signal, okay? So here are some examples through which we can check that if the signal is energy signal or power signal. Here this is kt, x of t is equals to k e to the power minus at ut. So here we can have that we have to check that if this signal is energy signal or power signal. So what we have to do, we have to just calculate the energy of the signal and power of the signal. So by the formula, E infinity is equals to minus infinite to plus infinite integration, and magnitude, that is amplitude of the signal, then square and then integrate. Okay, so for this one we are just using this one, so just replacing the value of x of t into this formula, we will get E infinity equals to k square upon 2a. Okay, so k square upon 2a, and here we know that a is greater than 0, right? So it is somehow it is a constant, and k square upon 2a, it's we can say that this is some sort of constant value, right? So therefore we can say that x of t is energy signal, and now it is not necessary to calculate the power of the signal, as we know that this is having some sort of energy and it is known as energy signal. So ultimately the power infinity, that is p average, will be 0, right? The second one is k multiplied by ut. So k we will just replace x of t over here by this kt, then it is k times of ut. So if it is, this signal is multiplied by ut, the limit of the integration ultimately changes from 0 to infinity, because this signal is available from 0 to infinite. Okay, and this is, its value is 1 over here, right? So this is again we know that if we integrate this over this range, okay, we will get E is equals to infinity. Hence we know that if energy is infinite, so then we can say that it could be the power signal, and if it could be the power signal, we will calculate its power. So putting the formula and replacing the values, we get that power is equals to k square upon 2. So it is some sort of constant value, hence we can say that this is power signal, right? So it is energy signal, this is power signal. So similarly, you can try both all these 4 numericals, so that you can have a clear concept of energy and power signal, right? So we will continue in the next lecture. Thank you.